Hi and Assalamualaikum. Today we are from Group 15. We'll present about Open-Ended Laboratory 2 SEAA3012 for H1, which is Streamflow measurement. Our lecturer is Dr. Muhammad Khairul Idran bin Muhammad. Each member has different tasks for this experiment, where I, Surya Ashikin, is going to explain more about the introduction and the objective. My teammates Yiseng Kang and Tui are responsible in conducting the procedures of the experiment, while Soli Yuen and Imran will discuss more on the results and discussion. For the introduction, in hydrological study, it is actually important to quantify the flow of rivers. The characteristic of flows are depth, cross-section, velocity, and stream discharge. The main equation in this experiment is Q equal to V times A, where Q is the stream discharge, V is the average velocity, and A is the cross-sectional area of the stream. These experiments also strengthen the understanding of conservation of mass, and the calculated discharge at nearby cross-section is actually same, even though depth and velocity are different. In measuring the flow velocities, we actually use two methods, which are current meter and floating object. The first objective is to obtain discharge value for upstream and downstream cross-section for current meter and floating object method. Next is to gain knowledge about river flows for operational management. Next is to strengthen understanding about the conservation mass concept at river pitch. Other than that, to select suitable stream cross-section in river gauging. And lastly, to use and appreciate safety gears during the river gauging. The apparatus that have been used are current meter, floating object, stopwatch, measuring tape, and stopwatch.
My name is Yi Seng Kang, and now we proceed to the procedure of current meter methods. First of all, this container is assumed as river. Then, indicate this is the inflow, while this is the outflow. Then, we need to measure the width of stream using measuring tape and divide into several subsections. So, this is the result that we got. After that, take the measuring rod to measure the depth of stream river at each of the cross-section. After that, the current meter is used to record the average flow of the velocity at each sections. And finally, repeat all the steps for the second stream cross-section. That's all for my part. Thank you.
Hi, my name is Tehon Bin, and I will now continue the presentation with the procedure of floating object method.
First, minimum turbulence at upstream cross-section is chosen. Then, the start and end point are marked. The start and end point are marked using a measuring tape for the travel distance of 3 meters. The floating object is dropped into a stream before the upstream marker. Stopwatch is started when object crosses the upstream marker, and the stopwatch is stopped immediately when it crosses the downstream marker. The measurement is repeated for 3 times. The width and depth of the stream are measured. That's all for the procedure. Thank you.
Hi, my name is Solian and I will now talk about the result. In this experiment, we have used two methods to calculate the discharge of flow. One is using current meter method and one is using the floating object method. This is the result that we calculate using the current meter method. By using the data given, we can get V average by sum up the V1, V2 and V3 and divide the answer by 3. Then we can get the VB by sum up the V average that we calculate with the V average in previous sections and divide the answer by 2. Next, the area can be obtained by multiply the D average with the width. Lastly, multiply the V mean with area and we can get the discharge value for each sections. Total up the discharge value in all sections and we can get the final discharge value for the upstream flow. In this case, the discharge flow is 0.1882 cubic meter per second and the total area is 0.513 meter square. Then we also had calculate the discharge value using the floating object method. We are given the data for 3 times of experiments, get the time average by sum up the times taken using in that 3 experiments and divide it by 3. Then the length of the river, which is 3 meters, is divided by the time average and we have the V average. By using the total area that we calculate in the previous slide, which is 0.513 meters square, and multiply it with the V average, then we can get the discharge value for the upstream flow, which is 0.2898 meter cube per second. By comparing the discharge value obtained from both methods, we have a percentage difference of 53.99%. So for the downstream flow, similarly, we also use the same way to obtain the discharge value. By using current meter method, the final discharge value is 0.2518 cubic meter per second, and the total area is 0.6768 meter square. And the discharge value for the floating object method is 0.2109 meter cube per second. The percentage difference between them is 16.24%. So that's all for me. I will pass the floor to Imran.
For the discussion, there is a difference between current method and floating method for both upstream and downstream. The percentage difference between upstream and downstream is 53.99% and 16.24% respectively. This difference between the discharge might occur because of error that we did during the experiment, such as there might be some dysfunction of the apparatus. Also, the parallax error may occur when recording the depth of water. And for the last one is the water flow was disrupted during measuring the depth. To prevent the errors, we must take the precaution. So the first precaution that we must take is we need to check the apparatus thoroughly before we did the test. The second one is we must ensure the current meter is the same direction as the stream flow. To avoid parallax error, eye level must be perpendicular to the scale of reading. Also, to avoid the parallax error, the other way we can read the measuring multiple times to obtain the average. In conclusion, the objective of this experiment is achieved where we find the percentage difference between the current meter and floating object method at upstream and downstream. The discharge at upstream using current meter and floating object are 0.188 meter cube per second and 0.290 meter cube per second respectively. Meanwhile, the discharge at downstream using current meter and floating object are 0.251 meter cube per second and 0.211 meter cube per second.
That's all for our presentation. Thank you.